Alright guys, let's see how we can solve on the question from the third chapter of the Meriam textbook in geomechanics. We have a woman that is holding a 3.6 kilogram sphere in her hand with the entire arm held horizontally, as we can see. We have a tensile force in the deltoid muscle that prevents the arm from rotating about the shoulder joint O. We know that this force acts at 21 degrees angles we can see, so this angle is 21 degrees. We need to determine the force Fd exerted by the deltoid muscle on the upper arm at point A, and also the x and y components of the force reaction at the joint O. We know that the mass of the upper arm is 1.9 kilogram and the lower arm is 1.1 kilogram, and also we know the mass of the hand is 0.4 kilogram, and we can see all the corresponding weights acting at different locations. So as always, we're going to start with free body diagram. So we are asked to find three different unknowns. We're going to start with the free body diagram. So since we know it's a horizontal thing, so let's just consider something like this horizontal in here. So we have a joint at point O. We're going to consider two forces in here, OX, OY, and we have the X and Y in the figure. So we have the force FD, which is our third unknown, which again we know it makes 21 degrees in here. We have the weight of the upper arm, and if we get back to the question, we have the mass 1.9, and we're going to multiply that by g, since we know weight is equal mass times acceleration of gravity. Since we have Newton, our g would be 9.81 meter per square second. So we have the weight of the lower arm, which we know the mass of that is 1.1, so 1.1 times 9.81. Again, in order to find the weight, we care about the weight, not the mass. So at the very end of this, we're going to deal with the weight of the hand, which was 0.4 kilograms, so 0.4 times 9.81. We also have the weight of this sphere, which we know is 3.6. So you can see that in the question, it's already multiplied by g. And that's pretty much everything that we have for this system. And we have three unknowns. We're going to get three equations from our equilibrium. We're going to have sum of all forces in x equals 0. That's 1. We have sum of all forces in y equals 0. And we have a moment equation about any point in this system. So three equations in total. We should be able to find all the unknowns in here. So we're going to start with the moment equations. Since we have the most unknowns at point O, if you just do the moment about point O, counterclockwise positive as always, we're going to get rid of OX and OY, and we can find the FD. And for finding our 2D shortcut, we just need to resolve FD into two components, one along X, one along Y. So the Y would be FD sine of 21 degrees, and the X would be FD cosine of 21 degrees. So it's easy enough for us to find the vertical distance from the point that we are trying to find a moment about, which is O in here, to the line of the action. And since we know that moment is r cross f, or it's also r times f times sine of alpha. Alpha would be the angle between r and f. When r and f are perpendicular, sine of alpha would be 1, because sine of 90 degrees is 1. So we just have to multiply r and f. No need to deal with the cross product and everything. So let's start with the moment of FD. So as we can see, the x component of FD is going to pass through O, so it won't make any moment. We have the moment of the y component, which is going to make a counterclockwise moment, so positive, and the distance would be the distance from O to A, which in the question we can see if we look at the figure, we'll see that it's 125 millimeter. So times 125. We can do the unit conversion in here and divide everything by 1000 in order to get it in meter, but it will be canceled out at the end, so there is no need to do that. But as I said, it won't make any difference. So we have the moment of the upper weight, which was 1.9. So yeah, if we look at this, we'll see that the upper weight is a little bit to the right of point A. So I tried to adjust the free body diagram because that distance is 130 this time. So it's a little bit to the right of point O. So the moment, as we can see, is clockwise moment, so negative 1.9 times 9.81, that's the force, and the distance is, as I mentioned, 130. We're gonna have another moment from the lower weight. This one's also clockwise, so another negative sign. Gonna have 1.1 times 9.81, and the distance is from, let me just clean up the, so it will be the 412 that we can see in the figure. And we have two more forces. We have the 0.4 and the 3.6. We can actually add these two together. So 3.6 plus 0.4, because we can also factor 9.81, and they have the same distance too, which is 635. And this will be equal 0. That's pretty much all we have. And from here, we can find our FD. So our FD would be the sum of all these divided by 125 sine of 21. Let's calculate this. 9.81 times 130 plus 1.1 times 9.81 times 412 plus 4 times 9.81 times 635. Divide that by 125, and we're going to divide that by sine of 21 degrees, which is going to give us 709.58 newtons. So again, the reason I didn't do unit conversion is basically we have to divide all of these by 1,000, which won't make any difference in our equation. So real doesn't matter if we do it or not. So let's move on to our second equation. We can do sum of all forces in X. We obviously have our OX, which is to the right. We have the X component of FD, which is to the left. So FD cosine of 21 equals 0. So OX would be times cosine of 21, 662.45 newtons. And the last one would be OY. So we're going to have OY. We have the Y component of FD, which was 709.58 sine of 21 degrees. And we're going to have all the weights in here. We can factor 9.81 in here and just add all the masses. So 1.9, 1.1 plus 4. So equals 0. We can find OY in here. 9.81 times 1.1 plus 1.9 plus 4. So minus 709.58 sine of 21. And this is going to give us OY, which will be minus 85.62 newtons. And the negative sign in here shows that the correct direction for OY is actually downward. We assume at the beginning upward, but that negative sign shows that our assumption was not correct, but the assumption for OX was actually correct. So it was positive. And yeah, that's pretty much everything for this one. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.